The payload bay doors open, revealing 2 GPS-guided bombs, destined for the assumed location of the then Iraq president, Saddam Hussein. Every facet designed to disperse and absorb the electromagnetic energy surrounding the skies around them. With the bombs delivered and their location potentially given away, the defenseless planes quickly turned to escape enemy airspace. A plane that looked like a fighter jet, but if it met enemy fighters, the subsonic plane, armed with bombs meant for ground targets, stood little chance. It relied entirely on stealth to get behind enemy lines and strike without being seen. The design began as a simple diamond that aerodynamicists of Lockheed's Skunk Works dubbed the Hopeless Diamond, a template for stealth. This paper, a Russian scientific paper translated by the Air Force's Foreign Technology Division, held the key to a new generation of aircraft. But this paper, unbeknownst to the Soviets, who allowed it to be published internationally, held the key to the technology that would allow aircraft to become the top predator once again. These were the only weapons on board. The plane would be completely defenseless to aerial threats and would thus rely completely on stealth. And because of this, the F-117 was going to be a subsonic plane. Here, things get particularly unique to the F-117. Radar bouncing around inside an engine inlet is like a person shouting into a massive cave. The engine inlet would need to take the same facet angles as the rest of the plane, and so the engine inlet was covered with a radar reflecting grid. The grid had spacing of just 1.5 centimeters. This spacing was key to preventing the transmission of radar. The passage of any wavelength larger than the gaps in the mesh would be impeded. The engineers wanted to minimize the heat signature of the plane as well as the radar signature. To do this, they needed to cool the exhaust and distribute it over a wider area so it could mix with ambient temperature air quicker. The exhaust outlet transitioned from a round duct at the turbine exhaust to a flat 17:1 rectangular shaped duct. The duct was also divided horizontally into smaller ducted channels. Below the exhaust, the fuselage extended out with a slight upwards angle into what was dubbed the platypus tail. This shape spreads the heat from the exhaust over a larger area, allowing it to mix with ambient air and cool down faster.